And hi, everyone. This is Jim Hong from Line Taiwan, and I'm an engineer of Line Today and Data Task Force. And I'm going to represent you how machine learning helps Line Fact Checker. Okay, this is my agenda today. I'll focus on how we put all the technology together instead of going too much detail. Let me start from the need for the fact checker. Okay, so as we know, today the fake message impacts our life a lot. For example, the fake health message might impact our lives, and a fake political message may impact our future. And the diagram shows that the severity of the fake message around the world. And the red circle area is one of most severe place, which is Taiwan, unfortunately. So that's why we need to build the line fact checker. Okay, so for Line Fact Checker, we provide an official account of Line. So when user encounter a message and does not know it is real or fake, he can just send to our official account, and it will provide the verified answer of is it fake or real. But when the message is unverified, and user can still choose to report this message to our system, and we will dispatch it to the human expert for verification, and then notify the user afterwards. And we also have a dashboard showing that the recent verified messages, and also the popular ones. Okay. And where are the machine learning usage? So today we know AI is getting so hot and so powerful. So maybe we think we can just build an AI that knows everything, so it can check all the fake messages around the world. But unfortunately, we are still far from this stage. Even the internet giant like Google, Facebook, they relies a lot on human efforts. So here at Line, we use the human AI collaboration, where human experts do the message collaboration and machine learning to explain its message coverage. So again, when user do the query of the fake message, the AI machine learning-backed near-duplication service will check if this message is semantic similar to the verified one in our database, and return a result to user. And when user report a new message, it will use the machine learning-backed classification service to classify the message into like health type or like political type, and dispatch to the human expert for verification. And I see in a message coverage point of view, so there's almost unlimited fake message around the world, which is in a dark blue circle of total message. And unfortunately, the verified message in a yellow circle only contribute a very small portion. So here we use machine learning-backed near-duplication service. We can expand the coverage from the verified message into a similar message. And then we use a classification service that can speed up the expanding of the verified message, since the human effort has been reduced. And therefore, it can also speed up the coverage of the similar message. Okay, here is some example that what near-duplication service solved to determine the semantic similar message. So for example, we have verified fake news, which is Captain America and Captain Marvel get married. But sorry to the Marvel fans here, it's just a fake message. Hopefully you don't get offended. And then when user query different kinds of message, like the first one is the partial match, which the message is part of the original message. So we treat this as the similar one. And the second one, the wording has changed, like the married changed to weddings, but the whole sentence still have similar semantic. So we treat this as a similar one as well. But the third one, although the grammar and syntax are similar, but it's changed the subject from the Captain America to Iron Man. So this is not similar. So we need to solve all these use cases. So in particle, our system, we divide the message into several types with different approaches. For example, the shorter text, we apply the strategy of the partial match and some fuzzy tolerance. And for longer text, we use the full text match. And we need to combine all this into a pipeline to ensure our performance. And for a full text match, we are leveraging the BERT model, which is one of the state-of-art NLP model. And the advantage is that it can extract the vector from the message, and it can capture the semantic based on the context. For example, apple means fruit in one context, and it means the iPhone manufacturer in the other. And third one is a Chinese pre-trained model that it can ease our work. And for a classification, when user query a message like this, again, this is Captain America example, and it will classify the topic probability, for example, the art as 49%, which is highest one. And for example, the sport has lower probability. So we can choose the highest one as its main topic. And in a model point of view, we still leverage BERT and plus additional network layer. And we also train the fine-tune model for the accuracy and pre-trained model for the speed. And then what about the machine learning system? And how do we put all this model on production and keep improving? So this is our machine learning system. We have the serving layer to provide what is called the Near-Duplication service and the classification service. And we have training data ingestion layer to get the reports from the user for the new messages. And we have the scheduling using Airflow and the execution management using Severity to manage the training tasks. And for the model management, we leverage MLflow. And deployment, we are using an in-house platform as a service, like the keynote said, Verda, and it's built on top of the Kubernetes. And for the optimization, because we are doing some similarity check, so we leverage index-based vector search, like NN, for the performance improvement. And then, of course, there are many challenges and some future work required. And the first one, we are getting more and more messages that contain not only text, but images. So we need also employ some image similarity mechanism. And now we are surveying the VGG16 algorithm, and it's kind of CNN neural net. And it can capture image features such as object and shape. So again, in this Captain Marvel example, you can see there's different similarity between different angle of messages, images. And the next challenge is that sometimes we will get many duplicate report message and getting stored in our database. The reason why is that when two new message comes in, the first one will be treated as new, of course, and goes to the training process. But before the training process is done, the second one comes in, but the Near-Duplication service still treated as a new because the training process is not done. So all these two messages are stored in our database and result in duplication. So our strategy here is we do a very quick cache layer here. For example, using a hash or index-based search engine to filter the most similar message when it's getting reported. But many messages not so similar, but semantic similar. It still flows in our database. So we still need another housekeeping process to find all these similar message by Near-Duplication service and merge all this message. Okay, then, and the last one is that we are thinking about applying the knowledge graph model because all the message in the world can be decomposed by different statements. And if we can build the facts of all the knowledge model, we can inference more fake message and determine it is fake or real. But the challenge here is that how can we build this knowledge graph model and how do we fusion with other model? And we still have very long way to go. Okay, thank you.